Oh. And today, work on the programming language again. Today we try to do this. I try to implement generics. It's 6:19 a.m. and you didn't have slept, and I am now online. Is it too early? How long do you sleep for? Because usually you come when, like, right now it's 9 a.m. for me, and like you come when it's like 2 p.m., which means that you sleep for like 5 hours only. That's so. All right, this says dependent types. I'm not sure if what I'm making is actually dependent types. Let's just call it generics. With quotes here. Hello, Devninia. But now that I'm online, you're actually just going to skip sleep today, right? Basically, because you cannot miss a cast stream, right? Two nights in total, 9 hours. You having problems with sleep, or you have too much stuff to do? Um. Yeah, so what we want is to be able to have generics. Specifically, one of the things is being able to write the ID function, which is taking the t as argument, which is a type, and returning a function that takes t and returns t, like this, right? So right now this is erroring out. And then I want to print ID hi. ID hey. ID string hey. Right, there we go. That's how we're supposed to use it. It is right now actually is working, but that's because because I like originally it's inferred as error, and then this overrides the type. Um and yeah, it's not going to work because it's not working if I try to use it twice with two different types. Int32 to string, like this. This is not going to work. I mean, it works, but type checking doesn't work. All right. Because we ignore the errors, so it works. It's like a dynamically typed language, kind of. So how do we make this work, and why does this not work, right? So the problem is that this over here, t, is a type, right? And we return from this function this thing. In order to return this, in order to compile this, we need to figure out what this type means. So when we're trying to evaluate this thing at compile time, but this value of t only exists at runtime, so we fail. That's what's happening here. So what we need to do is actually relatively simple. We need to say that if I see a value without a value, a free variable, a binding, then we keep it as is. Okay, how do I do that? I think it's in the interpreter. Wait, is it in the interpreter? Hold on. If I just do this, there is still error into error, right? So since there is error, should have seen some errors in command line, but I don't here see any errors. Which is weird. Right? So I'm not reporting the error sometimes, even although I'm reporting the value error. And specifically in this case, it's a type error. The error. It's not because of inference. That would say that type check failed. Because of something else. It's this over here, right? I'm trying to evaluate a type. And this over here, I expect value to be a type and it's not a type. So there you go. I want over here to say error, expression span, expected a type. Got this. And what did I get? I get value type of value type print. This is actually going to look a little weird, I'm pretty sure. Because here's, yeah, now I see the error, right? It's actually highlighting it. Here's what it's saying. It says expected a type, but we got a type. So why is that? Because this is a type without having a value. It's an abstract type, right? It's a type argument. So it's a little weird because of that. So we actually so actually when I'm expecting a type, it's not necessarily like already known as a type here, because it also can be a binding. In this case, we're going to return some inferred type, which is T binding. Yeah. Yeah, that's what needs to happen here. But my types, they don't have a variant, which is a binding. I think I introduced the bindings as values last stream, actually. So now we also have type values as bindings. T binding of binding. There we go. I need to do LSP support. Let's actually do this not here. Let's do it over here. There you go. Print. So if I am printing the binding, then what do I print here? I guess I just print the binding itself. And then when we have inference, if I have two bindings, they can only be merged if it's actually the same binding, right? So binding A and binding B, we only do this if A when is B. Binding is this thing. It has symbols, spans, types, labels. Like, I want these to be physically equal. There is no mutable fields here, though. Why not just make a to-do app? Vibing creator. At some point, we're going to make a to-do app. Deagle, you are Kuviman, and you are Deagle. I just need to make the language good enough so that we can make a to-do app in it. With my own programming language, yeah. Just not... possible yet, I guess. This is OCaml, yes. Physical equality. Maybe this is just going to work. The language for nerds. Exactly. LSP hover. Completion. Types T binding. Okay, it supposedly compiles. Does it mean that it works? Who knows? Let's see what happens. If I look at hello, this is now saying, there you go. So now ID, this is a function that takes ID as an argument and returns the function that takes T and returns T, which is how it's supposed to be, right? But the question is, what is T in this case, right? Because I guess in order to show this type properly, we need to say that this is t. The first argument that we give to the function is t. Rust is a good language that no one cannot be asked to use. I literally was using Rust before switched to a Camel. This project is a rewrite of my project in Rust. Rust is a good language, yes, I agree. But it suffers from too slow compile times. OMG, when are you going to activate Linux? When I become rich, when I become a billionaire, then I will buy the Linux license, maybe. Or maybe when that happens, I already like finished my programming language and I already have written my own operating system and I use that instead, so I don't need a Linux license at that point. All right, so I'm implementing generics here in the form for now of just the regular functions. Right? Right. Like this. I think I just need to like print this a little better. Maybe I should like print the entire pattern here. So the type of this. Yeah, so yeah, let's see. How do I write the type of this function, right? Because I have written the definition, but not the type of it. And the type would be the type, it should be like t type into t into t. That's how I should be writing it. Wait, I don't support multiple arrows? Really? And my formatter deletes my code? Nice, beautiful. Why is that? Is my my syntax incorrect? Syntax rules. When we have right arrow. Oh, wait. No, never mind. It's because over here I don't have the thing specified, the associativity. Yes, I literally just don't have the associativity currently. Which means that I need to like have parentheses like this. Did I do this on purpose? I don't know. Some I kind of like the explicit parentheses here, but yeah. Okay, so this and this doesn't parse, right? Because the types can only have the types, but this is the entire pattern. We can like do it without specifying the types though, I guess. That would be a small limitation for now. Is this language going to be more performant than Ziglang? Potentially. I mean, is Ziglang the most performant language? Ziglang is a language that you can write low-level code in, so it's not. It's basically in the same category as C, C++, Rust, Zig. But this language that I'm working on, it is, even although I am planning to be able to do the low level stuff too, I'm focusing right now on the high level stuff. So I guess not for a long time, but eventually, yes, eventually it will be fast and faster than everything existing, of course. But I'm working on the more important features than the speed, because I think speed is not the most important feature of a language. Most important one is being able to write code in it, you know? But yeah, there are plans for things like borrow checker, like in Rust, which will allow safe low-level coding, unlike Zig. Okay, if I try now to say this, this is going to say that string is not t, right? Because, as we can see here, the type of ID is a function that takes a type and it turns t into t, right? But the thing is, when I actually apply this function with string being an argument, which is instantiating a generic, right? It still stays to be t. The t must be replaced at this point. So, yeah. That's what should be done. So for that reason, I should have a thing which substitutes the bindings. And then I do it everywhere whenever I am evaluating things in the interpreter, I think. I think I need to have a new thing that is called a substitute bindings. So I'll have a function that is substitute bindings for the value. Is going to take value and return a value. And type, which takes type and returns a type. Value. Maybe it should be called substitute value. And this is going to be called substitute type. Type. But in order to substitute, I need to have the list of substitutions that is available to me. Which is what? It's just the the variables in the scope of the interpreter, right? How was I doing this before? Let me open my old code. We have a trace substitute binding, which just takes the recurse cache, because things can be recursive, and then just the cast. Oh, I see. Just tries to look up all the bindings in the current interpreter state, I guess. Yeah, that makes sense. One of the things with this approach, though, is that it had like bad performance, but I guess I don't really care about performance at this point. Because like traversing all the values all the time on every simple expression is probably too much. How would I potentially make it fast, though? Before substituting the bindings, I need to know if there are any bindings to substitute. Maybe like each value should also keep some metadata along with it, which is the list of bindings that we have. Maybe. Hello, Veldek. Yeah, maybe. Technically for now I just need to substitute the types and not values. So this over here I'm going to do because I only have inference for types, and I'm going to do it for types only for now, I guess. For now. So this needs to have the option to look up bindings, which means that I need the scope. I just need the scope of the interpreter, not the entire interpreter state. But yeah, maybe we have state, which is interpreter state, sure. Okay. This is a substitution. Yeah, the type is something that is potentially not inferred, actually. So I'm going to match type variable, inference variable inferred, right? If it is none, then I just return the type originally, because not inferred type just keeps as is. And if it is inferred, then we say inference, we say just type inferred, substitute type shape using state, I think. And substitute type shape. Type, which is type shape. Type shape. So now we just match type. With. So if it's a unit, then we just return a unit, right? Let's see, unit, boolean, integer, string, character, tuple. No, tuple is going to be different. AST. So some of these, they are just like flat types. We just return them directly. Unwind token as a result type. Target, I guess, goes in the same category. Context type. Compiler scope. And error. These are the same things. Okay, but now if we have and type of a type, which is type also is the same thing. All right, now if we have a tuple, type, it says labels. Okay, so over here I return a new tuple where we have tuple is tuple into tuple map. Unbound module tuple, open util. This tuple is type tuple field tuple. And type tuple field tuple has a label and type, right? And we return label and type. Name and span. Label and type, really? Unused variable name. Yeah, no, this is not a binding. This stupid OCaml. And not infer my types properly. This is type tuple field. Type tuple field does not have names, right? And does not have spans. It only has labels and types. This returns a new type tuple field. Label and type, but type is going to be a substitute type. State type. There we go. Okay, then we have a function. Type function has argument and result. Argument, result. The function argument is substitute type. Argument, result is substitute type. Result. Unwind token has a result type. Result is substitute type state result. And binding, this is where we have the actual binding. So this is where we actually try to access the state, right? So we try scope, local scope, find local opt, binding symbol. Match this with none, then type. If I found it, then something needs to happen. There's no field symbol, it's name. Find local opt. We are trying to find this in the interpreter scope. So this is state.scope. There we go. So local is the interpreter local. An interpreter local has the value. Right? So we have value. Value expect type basically. So I'm going to match value expect type with some type, then we return this type. And if it's not a type, then it's an error. I know what the span is. Let's do that. Fake span. And I just say that substituted type binding with a non-type, because that should never happen. Unbound value. Yes, some value here. No, some match local value. There we go. In this case, type is type. Oh wait, this is type. Right. Yes, when I substitute the type shape, it's not necessarily giving me the shape here. That's right, because this can potentially give me the type back. Yeah. Okay, type inferred type. Yeah. Because binding can be still a not inferred type, I guess. So over here we don't do that. We just substitute the type shape. It just returns the type here. Maybe I just do this into type inferred. That works. Okay, it seems like this works. No, I need to just call for the substitution. And when do we call for the substitution? Every time anything happens. Every time I evaluate anything. Over here, we say result is this. And we return the result. Right? But before returning result, after I evaluated the type, I say substitute bindings, substitute type, state, result. And that's what I return. And also when I evaluate a value over here, I say let result be this. And then I substitute binding, substitute value, result. Substitute value doesn't really do anything though right now. But eventually it will. Okay, this might be everything that I need. No, it still says T is not string. Why is that? Let's see. Let's see why. Let's say this ID string is ID string. The type here is T. Oh wait, it's because it's not. Yeah. I understand. If this is a const and this is a const though, no, that's not changing it. So I'm trying to call ID with string. I construct this, which is an expression function. Excuse me, the definition and type. Yeah, I guess I must still substitute the types in the values too, because this type is stored inside of a value here, okay? So I need to substitute the values, okay? Sure, I think I will just do shape is substitute value shape, state value shape, and substitute value shape, state, interpreter state, value shape, value. I guess this also will return just a value eventually. So here we just match on the value. If it's a unit, if it's a boolean, if it's an integer, if it's a char or a string. And we just return the value. I have a tuple. A value tuple field is a thing that has a value, span, and type field. What's the type field? type. Value is substitute value. Type field is substitute type tuple field. Map function field substitute type tuple field state. Like this. Substitute type tuple field state field is that. If we have a type, then we say that this is still a type, but we substitute the type. If we have a function, a native function, AST, AST goes there. Substitute type, state, result type. Value target. Value context type, value binding, value error, compiler scope. I think these two also are going to be as is. Native function. Native function just has the type function. Native function, let's see. Name, type, and impl. Name, type, and impl. Type, impl. But I think type is substitute type function. Which is this. And substitute type function, state, this type function, turn this thing. Okay. Now, if I have a value function, which is this definition, type, and captured, then I return definition, type, and captured. Definition. This is maybe compiled function. That is going to keep the same. Type is going to be substitute type function type. Captured is going to be the same. Now we just need the context type. Context type. This has a ID and type. Right? We return context type. ID type is substitute type, stage type. And now we have the binding, which is where I do the same thing as over here. So we try to find the local thing, but it's now yeah, if it's none, then it is just a value. Shaped, I guess, right? So we keep it as binding, but if we found the local, then we don't expect it to be a type. This is just a value, and that's what we return here. If we have a local, then we just say local value. Unless I need to substitute that recursively again, but I don't think so. Maybe, I don't know. Let's see if it works. Well, we still have inference errors. Type check, T is not string. This is happening when I'm actually calling the function, right? Is what it seems. So I'm calling the function and that results in type checking failure. String is not T. Can we name cost then? What do you mean? What do we name cost? The operating system written in cast is KOS T. So when I call this function, we evaluate this. This over here is a function expression. Type check failed. The better errors for type checking, like where is this coming from and where is that coming from, would be really nice. I don't have that yet. So I substituted it in one place, but didn't substitute in the other place, I think, is what's happening here. How about we got function arguments? Did I not substitute the arguments though? I'm pretty sure that I did substitute everything that could be. Maybe I'm just not like maybe I want to log something, see what happens. Oh wait, maybe when I pattern match. No, there is no wait. Why would I need to do it when I pattern match? No. But the patterns are never. But I'm never substituting the patterns. Yes. Let's see what should happen, right? So I'm trying to call this function with t being a string, right? So now t should be string, which means that basically we want to... Oh, I know. I understand why. I understand why. The thing that's happening is that what's the type of ID string, right? So I have inferred that the type of ID string is t into t because I did not run this code yet, but the actual value of this is string into string. That's right. Like the actual value here is string into string, right? If I try ID string, this is still t into t. But I think that's what's happening here. The type before I actually evaluate this and with the type after I evaluate this is different. So the type checking fails over here. What if I try just ID string, right? Then that works. What if I try to look at that? Then it says t into t. And then what if I do comp time ID string? Then this is string into string now, right? Okay, so technically, when I evaluated ID string, this returned a function that is just returning string into string. Yeah. That makes sense. I think in my previous version, I had this. So like this is a normal function. It is not like a special generic thing, right? I think in my previous version, this was only working for my special generic things, and I maybe was not type checking them actually. And in order to type check this here, I like this is like proper dependent types, you know, which is why. It is weird like this. Yes. How would I like, for example, I can say this const ID string is this, right? Then this will work. This is string into string. Like if I do the comp time thing here. Which is technically how this thing is supposed to work anyway when we do const, but yeah, I guess if I do this, then I evaluate this first and then decide just based on the type of the evaluated thing. And if not, then I try to compile this by saying that the type of this is going to be equal to that before running it. That's the difference here. So yeah, and then we can have ID int32, which is this with int32, right? Because now I can call this function with different arguments, and we have as a result two different functions specialized. So we can call id string, and we can call id int32 like this, and that's working, right? Okay. So the problem is that, yeah, I understand. So yeah, the problem is over here. When I say that id string is id string, right? What is the type here? The type is t into t. This is the problem. Because t doesn't exist in this scope, right? It makes sense to say that the id itself is a function that takes type. This type is going to be basically assigned to t, and then we can return t into t. But it doesn't make sense over here. It should not work with lets though at all, I think. I'm actually wondering, is this code going to work in my previous version? I don't think so. If I try saying that let id is t into x, t into x, then id is type into t, that's actually correct. Okay, what if I say id string? Then it's going to say expected binding t into t, and but result is string into string. Yeah, there we go. We literally have the same error as in my previous version. It says that we expected a string, but we got a t because the compiled version of this, before we run it, just thinks that the type should be t into t, but when we actually execute it, we substitute t with a string, and we get the type, which is string into string, and it doesn't type check anymore. As far as I understand, in languages with dependent types, didn't I clone Idris or something? Can I just run Idris 2 or whatever? Okay, we have the Idris REPL here, right? So can I say that let id x is x? No. Idris. Tutorial. Types and functions. We don't do a let, I guess. We just say that id x is x. No. id is wait, this is my language. id x is x. Undefined named x. Show me how to do a function. plus zy is y. Wait, this is literally how am I supposed to do it? What do you mean undefined x? Who x is x? Who? Net into net. It doesn't work. Maybe I need to like maybe it needs to be a let, like a colon let in this REPL. Let fx is x. There we go. And then type of f is this. Not unknown into unknown. Okay. That's literally the way we work too, right? If I say let f is x into x, then type of f is underscore into underscore. That's the same thing. Okay. What if can I have the type annotations though? Let f x that is x. Going to parse declaration. Can you not have inline types? Maybe you cannot. Yeah, you need to like have it on a separate line. All right, I don't know. It will take too long to test it, I guess, unless I actually want to learn the language. What am I trying to do here? Do I just disable? Like, I feel like I want to say. So, what is the type of ID string here, right? What is the type? It cannot be a string into string yet, because we did not run this code yet. So as far as I understand, the type of ID string should literally be ID string. No, ID string is different. It's like some unnamed type here. How did I do it differently then for the generics previously? I think I know how I did for generics. I actually execute. Yeah, so in order to evaluate the type of ID string, for generics, the arguments, they must be known at compile time. That's how I did it before. Yeah, that makes sense. Because if we know the value of this here, then we can know the actual result type. So yeah, I cannot do the, yeah, I did not do dependent types. Yeah, sure. Okay, fine. Let's do actual generics then, and they will have a little bit of a different semantics than these functions, I guess. So for generics, we just do a little different syntax. The argument is going to be in square brackets or something. Previously. Do I want a keyword here still? I kind of like it without a keyword. It's like a lambda, just a little slightly different syntax, but Then it might clash with indexing if I want indexing to be with square brackets too. The keyword is a little bit too verbose though, maybe. What about at? I don't know. I don't like my old syntax, and I'm not sure what I actually want. Let's start with just pure square brackets. Okay, so similar to functions, I'm going to have similar to functions, I'm going to have a core generic. I'm going to have a generic which is going to have the argument into body. Right? But the argument must be enclosed in square brackets. Something like this. Let's see. So this works. If I have like two generic arguments, and it's going to look like this. If I try to split that, this should wrap, if any. You said angle brackets often for types. Yeah, I don't like it though. I don't like the angle brackets. I like square brackets more. Square brackets are used by Go language and Python, for example. There are a lot of alternatives, but square brackets actually make sense. Square brackets are also used for indexing, right? And generics are indexed types, basically, because like ID is not just a function; it's a generic function, aka a family of functions. So when you try to get the, it's like an infinite array of functions, and if you index it with a concrete type, then you get the concrete function. Neem uses square brackets too? Yeah, maybe. So like square brackets make a lot of sense to me. And they don't collide with indexing, because that's what it is. Anyway. I'm trying to figure out why my formatting is formatting the thing incorrectly right now. Maybe I need to restart language server? There we go. Yeah, that's what I wanted. So my formatter is formatting like this. If I want separate lines, or just like that. Okay, nice. Now I just need to implement the core syntax generic and stuff. Also, I think this arrow is not needed. I think I don't need the arrow here. We just literally do space and then body. Right? This is just a generic function. Is colon type necessary? No, it's not necessary. It's just a type description. It's supposed to be inferred, but the reason why you can specify it here is because the generic arguments are not necessarily types. Because you can have generics that you can be generic over other things than types. For example, an array, right? An array is a generic over over the integer, which is the size, right? And this returns like some type basically here. These are called const generics usually, but I don't want them to be separate features. It's literally the same feature. We treat types as values. Types are nothing different than any other value for me here. But it is automatically inferred to be a type because I use it in type position over here, because I use it in type description, which is why t is a type automatically. This is not necessary, but it is going to be inferred. And like this return also is technically can be inferred, right? I can do this. Even shorter description of the ID function then. Okay, so let's do core syntax. I need to implement the generics now. Which is going to be similar to function. Generic. Let's copy function and see what's going to be different. Okay, function has the argument. I mean, generic, it has the argument. It just doesn't have the context, like the functions. Maybe we'll see. And then we have the result. There, the result type is also not necessary. We just have the body and argument here. Expression. Type. Generic, I guess. I will need to create a dedicated expressions and values and types for it. This is copy pasta. Can I make it not be copy pasta? To do copy pasta with a function. Okay, so we need to have a expression generic. Expression generic. I think expression generic, it should just not. Like, I don't care about the types here because I cannot type check them properly right now. We just have the definition, which is still generics are under the hood are going to be just functions. That's probably is the difference between my alt code. Let's see how I did before. So I have a value which is a generic. I called them templates before. Yeah, see, a function is a typed function, but a template is just a function, like a dynamically typed thing, basically. I guess. I guess. Let's create the value and the type at the same time, I guess. So I will have a value generic of a value generic value function, and value generic is definition. Let's do this. Function is function and function, and value function is, this is like a typed function, right? So this is the function. Untyped function, value untyped function. Let's try that. And if I have a type, then I just give it the reference to the same function, I think. So type generic is going to be also just the function, which is still going to have like the same thing, value untyped function, I think. Let's see what I'm printing. Generic. Print generic. When I have a type generic, I think I just print generic for now. And then if I have expression generic, is it just going to be generic instead of a function? All right, when I have a, so now when I get a value, a type of a generic thing, then it's going to be type generic, just like that. Now for inference. For inference, if I have two generic functions, two generics, then they must be the same only if I don't know, just when A is equal to B. Maybe, I'm not sure. Let's keep that for now. Substitute bindings. Now when I substitute the bindings, yeah, this should be like function. Right, and then we have value generic function. Just keep it as is. Nothing to substitute here. If I have a type generic, nothing to substitute here either. When we have interpreter, this is just me refactoring a little bit. Function is function definition function dot captured. So yeah, now I can call maybe I should have like a call impl here. Let's have call untyped function, value untyped function. That's what I want. So this would be call untyped function span state function argument. Right. Now this doesn't need a return. Okay. So yeah, because I want to have a difference between actually calling things and instantiating generics. So that I will have instantiate generic, which is a value, and with the argument like this, expected generic, value generic. It has a function inside, and I just call the untyped function for now. And then later we can add memoization here. Gold scrolls, hello, hello. How are you doing? Welcome. So now when I have a expression generic, this thing just will not have the type, right? And it will only have the definition. It will be a function generic, value generic. Yeah, over here we say that function is definition and captured scope, right? And then I just do the same thing over here without anything else. That's my generic. All right. Compiler init. So what is the type of expression generic? That's the question. What's the type of expression generic? Let's do a new not inferred type for now. We do. The LSP. LSP completion. Type function. Is there like a dedicated thing for generics? There is this is the icon for the LSP to show in this auto completion actually. Is there dedicated icons for generics? Variable value unit, type parameter, text, struct, snippet, reference property operator module, interface, function folder file field, event enum constructor constant color class. I don't know, let's keep it to be a function for now, I suppose. That's just the icon, it doesn't really matter. Over here, I just add some to-dos. Okay. Okay, type check failed, underscore in the underscore is not generic. Yeah, because generics and functions are different things now, right? I do not call these things now like this. Instead, in order to instantiate a generic, we also use square brackets. I just do id string like this, which means that I need a new syntax to instantiate generics now. Instantiate generic is just going to be generic be instantiated with an argument like this. Priority should be different here. You don't understand any of this? Just here to support? I'm making a programming language. Do you understand programming in general? Are you a programmer? Is there something you would like to see in a programming language? If you are a programmer? not sure this is going to work. Actually, this should have like the biggest priority or something. Well, not the biggest, but probably like 1,000. Not sure about the generic itself, but maybe also. I'm not sure. We'll see. I'll play with this syntax. But this says parse error. Yeah, because yeah, it cannot be that. Or I guess this could be a right associative thing. Then it is going to work. And this thing is left associative for instantiating generics, I guess. Yeah, that makes sense. Okay. This parses, which is good. I just need to implement it. The core syntax. So, and then it also means that I need a new expression, which is instantiate generic, similar to calling a function. Let's do that first. Types. I have an expression call. It's called apply. And it's going to be instantiate generic. It just has the not function, but just generic, and the argument to expressions like that. Sure. Okay. Now in order to evaluate it, I already did that, right? Instantiate generic and argument, generic. I already have this function called instantiate. So that's already done. When I have the function, the expression instantiate generic, closest thing I know is circuits in factorial simple conditions. And that factorial circuits is basically a programming language, right? Generic argument. Yeah, so over here, how do we type, what is the type of the thing when I instantiate generics? That's a good question. Let's also have a to-do for now and have it be dynamically typed, maybe, is what this is going to lead to. Okay, expression. Apply. Instantiate generic. cover. Wait, what? Not. It's a transpiler. I guess I just have it to do here. I don't use a transpiler yet. Okay, now there is no core syntax for instantiate generic is the last thing, I'm pretty sure. So there should be apply. I can manually write. So you're programming to make your future programming easier in your own language. Yes. Will you one day be able to write your own programming language easier in the programming language you created? Yes, that's the idea. That's called bootstrapping, which is going to be rewriting my own language in my own language, right? Right now I cannot do that because there is not enough features, but eventually it's going to be like expressive enough so it can express itself, right? Yes, that's the plan. You can manually write and edit G code for the 3D printer, technically programming in the language, simple commands though. Yeah. I guess that could be called a programming language. Maybe. I don't know. I don't know. I never did a thing for the 3D printer. But it probably is. Apply. Instantiate generic. Okay, I'm just going to copy paste applying and say that this is instantiate generic. Instantiate generic has a generic and argument as two of its arguments. So I compile generic, I compile argument, and I instantiate the generic with these things. Instantiate generic must be expression. Yeah, I think that's all. Let's see if it works. Expected tuple got string. Yeah, that's right. That makes sense, right? So over here, because I was playing around with the code, this is a generic which takes as argument two generic parameters, but I only supplied one parameter, which is why this doesn't, it didn't work, right? But if I change this to t, then it's going to work properly. But we don't have any type inference because that's a to-do. I need to actually implement the inference now. Right? And by the way, we are going to have what? ID string hey and ID int 32 123, right? That's what we want to do in the end. Technically, this works right now, right? Technically, this already works, but the problem is that we need to know the type of ID string, right? So let x be ID string. Right, x right now is unknown type, but it should be string into string. Also, I guess it doesn't work if I try to make this automatically inferred. Well, I guess right now I'm not checking anything at all, so that makes sense. Yeah, because string is a concrete type. I don't know if I can make it break, but yeah. We can also make a function like, for example, yeah, I think what we can do is have a function like parse. Parse would be a function that is taking type t and returning a function that takes string s, string, and returns t, right? Somehow. Obviously, I have no idea. I cannot do that right now unless I do an underscore maybe here. No, underscore doesn't work because I cannot even write that thing right now. We will need like or maybe like it's easier to have not a parse. Maybe for now we just do toString. toString is a function that takes a value of type T and returns a string. Then I can have an actual implementation for this, which is like fake toString. For now, I can do that. And then if I try toString hello world, toString underscore hello world, let hello world stringified be this, right? Obviously this is going to be a string, but right now the inference is not working. Okay. So we want it to work, of course. But let me commit these things anyway. This is basically generics, but no type inference. Okay. So for type inference, I need compiler init over here. I need these to-dos. I need these to-dos. When I have an expression generic, the type here is not inferred when I but the generics are supposed to be known at compile time anyway. I guess I should not even be able to write. Yeah, I mean, yeah, I should not be able to write a let here. It's already a const. This so I think I just need to type check the instantiations. I need to like get the actual value here though. But this means also that when I'm instantiating generics, they should be available. So for instantiating generics, this should be available at compile time, which means that there is actually no no expression there, right? I should just evaluate this. Instantiating generics also can just work at compile time. No, it cannot. Because in case I instantiate generic inside of a generic, that would technically be a runtime. That's working at compile time. Let's see what I have, right? So when I have instantiate generic, I should be able to evaluate the argument here directly. That's one thing. And then, this generic, the type of this must be a generic type. which means that I need to figure out the type here. I have expression generic. Okay, let's see. I guess it should be type generic. Type generic takes as argument the function, which is value untyped function, which is the maybe compiled function and captured scope. And expression generic has the maybe compiled function here. And now I just need to capture the current scope then. Captured is state. This is compiler state, but compiler contains interpreter inside. And we can capture its scope like this. Maybe. So now when I instantiate generic, what kind of language am I making? The God programming language. I don't know how to explain it. The programming language that like my ideal programming language in theory. All right, it's the programming language. The programming language that's actually good. You know, finally, all the programming languages suck. We need to create the one that doesn't. Okay. But yeah. What kinds of programming languages are there? What, like, because I think like at this point in 2025, the languages, they don't split into like categories, right? Like procedural, object oriented, or functional anymore. I think that's not a distinction really, because all programming languages, they have like they are basically like multi-paradigm languages. Kind of. I guess most modern programming languages don't really do object-oriented programming, but I don't know. I don't know how to say it, but basically, I want to have a powerful language. It's supposed to be able to write very like high level abstractions. At the same time, I want to also be able to write low level details. So it should be both a low level and a high level language. Other kinds of languages, maybe like how do you classify languages? Some languages are compiled, some languages are interpreted. What is my language? The answer is yes. It is both compiled and interpreted language. Specifically, what one of the things that we can do is we can interpret the code while compiling. That's called compile time evaluation, right? So like Jai. Jai is another language that is like, yeah, like what kind of language is Jai? And Zig. Yes. But Zig is too low level. Jai is a little more higher level than Zig. But as far as I understand, it still is not as high level as like some other languages. I don't know. I didn't really try Jai because it's not public and I didn't ask for it. But in terms of compile time execution, yes, it is similar to Zig and Jai. And memory management safety. So the plan eventually is to have something similar to Rust, but different. But yeah, since I want to there are some improvements to make over the Rust system, basically. That's in short, I guess. But we want the memory management. We want it to be safe language. Yes, safety is important. With some like unsafe escapes, like in Rust. If you like really need, and if you cannot prove the safety to the compiler, you need to tell the compiler, trust me, I know what I'm doing. But by default, it should be just safe, right? Yeah. If you are familiar with Rust, then one of the improvements over it is you write a lot of Rust. Okay, so there is this thing in Rust that is called a ghost cell. My idea of the improvement of the borrow checker is based on the ghost cell, separating permissions from data in Rust. So in short, in Rust, when you have a reference to a type, what is this? What actually is a reference to a type? This is actually just a pointer to T plus permission to read this pointer, right? So a reference in Rust is two things in one thing, and what we want is to split these things into two separate things, because just a pointer can be safely shared, but in order to use the pointer you will need this permission, right? And similar to that, like a mutable reference is like a pointer. I guess we don't like, let's make no distinction between pointers that are mutable or not mutable. This is permission to write the pointer, basically. Basically a mut reference to T rather than mutable reference. Not exactly. It's basically this is a higher level type, and this is a lower level type. And what this will allow us to do, if you read the ghost cell paper, is it allows you to express some things that Rust is unable to express. For example, like recursive types, or like a linked list is a good example, right? You want a linked list where you have pointers back and forth. That's not possible to do with safe Rust, but if you have a system like this, it should be possible. Here is the simplest example of some code in Rust that would not be working. You say something like this: let mutable, I don't have the mutable keyword right now, so let's just say let x be 1, 2, 3, and then we have a closure that mutates x, right? This is a closure that just say like x is x plus 1, for example, right? Like this. So because this closure exists, it captures x by reference, which is why if you try to mutate x here, this is not going to work. The borrow checker is going to complain. Right? Because it will say that this is already borrowed in this closure. But this code is technically totally fine. So how do we make it totally fine? We make this closure only capture the pointer to x, but not the permission to use the pointer. But we get the permission back when we actually call this function. And that is going to be achieved using an effect system. So this function, the concrete type of this function is not just unit into unit. The concrete type is going to be that it allows a mutation of x with mutates x, something like this. So this function, like part of its type is going to be that it mutates x. and it is going to allow this, which is going to be also automatically inferred, so you don't really write it, kind of thing. So we combine the ghost cell idea with the idea of the effect systems. If you are not familiar with effect systems, it's kind of like being talked about in the Rust communities, the effects. Or take a look at like something like Coco language, which explains the effects pretty nicely, I think. Can you do a linked list in Rust with RC ref cell? Yeah, but that's has an overhead, right? You want to you don't do RC ref cell because that has a lot of overhead, basically. You want still to be able to, because that's no longer a zero cost abstraction. You know. Yes, you can do an RC ref cell, but that's a different thing. You can also just import a crate that does garbage collection and use that in Rust. Yeah, okay, but I am very far from implementing anything similar to a burrow checker. For now, my language is GSeed, I guess. I'm probably not going to focus on that anytime soon. I will rewrite the language in itself first, I think. Oh yeah, also another thing that this idea is allowing is that in Rust, to be honest, for references, you end up using indices into large arrays for linked test structures, which isn't a zero-cost abstraction. Yeah. The problem is that it's not a zero-cost abstraction anymore. But there are ways around it for sure, yes. One of the other things that, since I am splitting the pointer from the permission to use the pointer in the references, it also another thing that I will be able to do is I will be able to have a reference to the not initialized variables. And by doing that, I will be also able to initialize self-referential types, which is basically impossible in Rust right now. In Rust, you cannot have the recursive closures is another thing. Energy Star, hello. All right, let me just continue what I'm doing here. What I'm doing inference for generics, that's right. Type check failed, generic is not generic, of course. Nice. But also, I might be completely wrong, because like I have thought about these ideas that I have for a while, but I have not implemented them yet, right? So maybe like I'm completely wrong, and some of the things that I want to do is like impossible or something. But we'll see. Elemental Magics card game. Hello. This is a weird error. Type check failed. Generic is not generic. What do you mean generic is not generic? This is the only expression that I have. Let's look at the type inference, I guess. If I have generics, they must be equal. And we have the value untyped function. Interpreter scope. I mean, maybe like physical equality here in OCaml, it's a little weird. I need to like actually look up how this works. OCaml wrapper physical equality. Test for physical equality of these things. On mutable types, it's true if physical modification is this. On non-mutable types is implementation dependent. Okay. So yeah, I cannot use equal on the immutable types, which means that this is wrong. And yeah, and also like for bindings, this is also wrong, I guess, because bindings are also not mutable for me right now, unless I make a fake mutable field. But for bindings, I can have like IDs, I guess, ID. And then I can say AID is equal to BID. But then it should be not a double equal, but a single equal, right? And I guess the same is going to be for generics. I'm just going to keep IDs inside there. Generics. Type generic. I guess the untyped func. This thing itself is going to have ID. A function ID, B function ID. ID is ID gen. Wait, but this doesn't work. Does it? Because when I create, it's going to receive a new ID and a new type. Type. Do. This is a different type from evaluated expression since different ID. But for the sake of type inference, this should be fine. Okay, the type inference still failed. Why did it still fail? Why did it still fail? Maybe it's because of how I implement const. Let's see. I just do a const let here, pattern and value. So this expression is just evaluated, and that's it. Wait, when I do a const let, I'm not even saying that the pattern type should be the same as the expression type. Yeah, I think this should be inside of this pattern. Const let. Yeah, that makes sense. But that's irrelevant to my current error. It just says generic is not generic, right? Which means the only reason is that their IDs are not equal, right? Because if I just comment this, then it's going to be fine, right? Yeah, that's what it seems like. So the IDs are different for some reason. Generic. Oh, that's why. That's literally the to-do that I have written in here, because the type is different from the evaluated expression. That's right. I'm going to take a look at how I did it before. So it seems like the type of a template is just the compiled thing. It's just a maybe compiled function, that's it. I don't store the actual function there. Okay. Maybe that's why. Like this should not. Yeah, I guess basically what's the difference is that I was not storing the type generic. It's not a value untyped function. It was just a maybe compiled function, but maybe compiled function doesn't have this scope captured there, right? So how would I call it then? That's the question. How was I call it? I mean, let's try doing the same thing. So if I have a generic type, then it should have the compiled, which is maybe compiled function. That's what you want. Function definition. I guess it's called definition. And now, since the definition, since the definitions are mutable things, then I just say A is equal, physical equal to B. So over here, we just store the definition, and I don't like capture anything on half the IDs. That simplifies things. Let's see if this works. Okay, so this did not have any issues anymore. Okay, but then I need to type infer the instantiation of generics. How would that work? Or maybe I was just evaluating the generic here and the argument. Maybe that's what was happening, and then I just literally instantiate and get the type. Is that what I was doing before? Probably. Can I get this using just the types? Because the type will contain the definition. Sure. But then in order to instantiate, I will need to get the captured scope too. expression instantiate. So yeah, I figured out what's the template type. Result. Compiled. Template type. Must be compiled. I evaluate the argument. But evaluate the argument in what scope? In literally just the current scope? Isn't that wrong? Is the type resolution? You have it running async? Yeah, I have. This is the old version over here. This is the old version in Rust. I'm right now rewriting it in OCaml. My previous version in Rust had more features, but the new version has more editor support. The entire compiler is async, yes. It's very similar to like lazy compilation, but it's async compilation. So I don't like only calculate things when they are needed, but I try to calculate them immediately, and then if they need some more information that is going to be available later, I'm just waiting for it. For example, when we have a recursive scopes, right? When I'm referring to a symbol that is defined later, I'm literally just awaiting it. And another thing that we wait for is for the functions to compile, because in order for functions to compile, they might potentially like need some things to do. So Zig has the lazy compilation model, and we have async, but it is really very similar. The need to detect circular dependencies up front. Well, I don't do that, no. Why would I need to do that? I'm making a programming language, but it doesn't mean that I know what I'm doing. But so far it has been working out pretty well. I am definitely not doing the traditional way the compilers are being written. I don't have phases, for example, in my compiler. My compiler in the interpreter is the same thing. The compiler is the interpreter. I can compile things while parsing and interpret things during the parsing phase. That's how the macros work. Speaking about the difference between my programming language and Rust, we will be able to write macros as just regular functions. A circular dependency would mean two awaits waiting on each other. Not really. Like, what is a circular dependency? Well, I mean, yeah, I guess potentially that can happen, but how can that happen? I guess we should detect these things. But how do you write a code like this? Because here's the example, right? This is just mutual recursion, right? We have a function f, which is calling function g, and then function g is calling function f, right? So we have circular dependencies here, right? But how does this work actually? So this works because I'm trying to compile this function. While compiling this function, I'm seeing the symbol g. So I'm pausing the compilation of this function, and I'm continuing to compile this program further. So now I see that there's a function g, right? I'm trying to compile this. Function f at this point is already defined because it's earlier than f, right? So this is going to compile successfully, actually. But it doesn't even matter, because even if not, then the g, after I have compiled this, now it is defined, and now anything that was defined previously that was waiting for g to be defined can continue working. So I'm going to continue compiling this function later, right? So it's not like exactly a circular dependency, right? Because when I say that this function depends on g, it depends on the declaration of g, not on the implementation of g. These are two different things, right? So there is right, there is a like f the symbol, there is g the symbol, then there is f implementation and g implementation, right? So f the symbol doesn't depend on anything, g the symbol doesn't depend on anything, but f implementation depends on g the symbol, and this, and g implementation depends on this, right? So there is no actual like circular dependencies here, right? One thing that I don't have right now is recursive types, I guess. I only can have recursive functions. But for recursive types, I kind of do the same. I split the declaration from the implementation. In terms of types, the implementation is the concrete type. So we can have type variables with no values, like the not yet inferred types, basically. So yeah, it's like just a reference to the type, basically, and then the actual value of the type is like they are split, and because of that, we're also not going to have like cycles there in terms of dependencies of things waiting for each other, if that makes sense. Instantiate generic. Let's generic. No, wait. Yes, this is initialize expression. Oh, yes, this is initialize expression. It's not like typing. Okay. I can do everything here. Generic is generic type is generic data type. With return. Let's see, I'm going to do this, and I'm going to match this into inference variable await inferred. With return error. What's the problem here? Expressions type, type shape type. This. There we go. Okay, so the type of a generic must be a generic type. So I do this. Okay, that's the generic type. Type generic. Okay. And then I say that argument is... Now this needs to be evaluated. I literally just evaluate it using the current interpreter state. Is that what I do? Also, I'm pretty sure that over here I can fork. Let type be type new not inferred in. So we fork and then we return type. But then I say that yeah, so this is yeah, we just do type inference type expect inferred as this. Inferred type is that. And span would be expression span. Okay. I have generic type, I have the argument. And I just need to apply them. I do need to say that the yeah, so this is a generic type. I also need to wait for it, right? Definition is generic type. Generic type literally just has the definition, right? Type generic. Let me keep interrupting, but why I switched to OCaml? You're reading a language in Rust and some of it is pain. The only reason that I switched was because of the compilation times. I don't know what pain are you experiencing. For me, writing it in Rust was pretty simple, I would say. But a compilation time is the only pain point. I've been using Rust for a long time. I'm pretty comfortable with it. And I usually don't have this a big problem with compilation times. I'm making a game in Rust with a custom engine and everything, and I don't really complain about it that much there. But my language, because of the way the language that I'm writing works, because of its highly recursive nature, splitting the language into crates is very difficult. So it's basically a single huge crate, and that's really bad for the Rust compilation times. Also, I'm having a lot of generics and like async code, which also doesn't help. So yeah, that's it basically. So over here I have the thing running, right, and stuff. This is the old version in Rust. If the only thing that I do, now that I have figured out how to show it, if the only thing that I do is rename a thing, All right, let's say that I rename this tuple to tuple2, right? That's the only thing that I'm going to do. I'm going to save this thing, and I'm going to just rebuild it. This is going to take a minute, which is too much, basically. That's when I switched. And it was like as I was growing, as I was working on the language, it was slowly growing, and then when it became over a minute, that's when I decided to switch to a camel. But as a language, Rust is better, in my opinion. And if not the compilation time, I would keep working in Rust. But a minute of wait for the debug build is a little bit too much. Yeah, I don't know. Do you have any other pain points? Self-hosted eventually? Yes. The short-term goal is to solve the advent of code, which is in 10 days, is in the language. Eventually self-hosted though, yeah. C compilation might not be too much better, but at least it will stop you from doing generic stuff. What? Yeah, see, 1 minute 10 seconds for renaming a thing. Okay, that's pretty consistent at being this thing. Also, I was actually debugging the timing, right? And you can see over here that my compilation times are big. Over here, this is the timings of Rust compilation. Type checking the crate takes 20 seconds. Borrow checking takes 20 seconds. Monomorphization takes 20 seconds. Generating crate metadata takes 20 seconds. So that's a total of 66 seconds. Yeah. Cargo check is better, but I guess cargo check is not going to, I don't know, generate crate metadata maybe? I don't know actually. I mean, checking is still really bad because checking still needs to do the borrow checking, right? And it still needs to type check. So like it would still be like 40 seconds or whatever. So yeah. But if you can structure your code in Rust thinking about compilation times ahead of time, then like it doesn't have to be like this. But I would need to rewrite everything, and like I said, it's not really easy to split my language into crates. The pain for you is that you haven't written the compiler before, and that's very language agnostic. Yeah, I mean, I haven't written the compiler either, but what I'm doing, technically, I'm not doing a compiler, right? I'm doing an interpreter. And yeah, I don't know. Maybe, I think that's a lot easier than going directly into compiler. I have the compiler in mind, like in plan, right? But I need the interpreter anyway for the compile time evaluation. I have right now actually this thing, which is in my previous Rust version, I had the transpiler to JavaScript. In the current version, I think I'm going with transpiling to OCaml. So that's how I'm going to get the native binaries instead of just doing like calling into like LLVM or whatever myself, because that's a lot of work. I don't want to do that. I don't even have like bytecode. My thing that I'm running is really high level. This is the thing that I'm running, right? That's the language. If you can consider this bytecode, right? I have the expression function, expression tuple, expression apply, a function, assigning, and like all of these things. I guess this is kind of like a bytecode, but it's not really bytecode because I'm not serializing it anywhere. It's kind of like an AST, basically, that but it's not exactly AST because it has the type information, right? Already when I'm evaluating it. So it works. My language works kind of similar to like to like your normal scripted languages, but the idea of how the compiler would work eventually is that, like, for example, in Python, you can get the source code of a function, right? But I am going to be able to like inspect the function like more. Like I will just have more information available to me, I guess. So that's the idea, is to be able to write the compiler inside the language itself. And have it as part of the script itself. I don't know if that makes sense. But the idea is to be able to run something like this. Like, let's say that I'm making a game, right? I want to be able to run some, to write some shaders also in the same language. And then because we have the compile time evaluation, we will just run a function that is called transpile at compile time. And that's how you embed a shader written in my language itself into the final binary by just running a transpiler during compilation time. So a transpiler is basically like just like anything else, is going to be ran through the interpreter. Right? I don't know if that makes sense. But yeah. Something like that. Kind of like in Zig, you have the build system being a part of the language standard library, right? Something similar to that. But I don't think that in Zig you can run the compiler as part of the comp time evaluation there, so it's like a little separate there. So yeah, basically the compiler is part of the standard library, right? It's not like a separate thing. And you will be able to run the compiler at compile time. And compile time is just the evaluation time. It's, yeah. And I need to figure out how to explain these things better. I know it's kind of like obvious to me, but it's just very different from how the compilers usually work. Similar to eval in Lisp. Yeah, but like Lisp is normally just a scripted language, right? There's no compilation step. I still have the like compilation thing. So even so like the way my interpreter works is that I'm still kind of like parsing the things. I'm like parsing the things into an AST, then that AST is being converted into what I call the intermediate representation, but that's the high level intermediate representation. And then that thing like type checks and everything, and then I interpret this thing. So the compilation step for me right now is this conversion from AST into the intermediate representation. And then if we want to have the actual compiler to native code, then that's going to transform the intermediate representation further It's kind of like in Rust, you have the MIR, right? The medium level intermediate representation. And then Rust actually also has the interpreter for that, which is called MIRI, right? Something similar. MIRI is kind of like a high level, right? Rust MIRI. I never like worked with it directly. We can, I guess you can see it in Rust lang here. If you try build and show the MIR, yeah, like this thing. That's some wrong code. Let's just do println hello world. It's basically like just a little lower level than the yeah, see, like this is the result, right? So the MIR, the medium level representation is literally just the Rust code, just more limited, only like the minimum amount of features that is needed, right? I'm doing the same thing, I guess. But LLVM intermediate representation is different because that's a really low level. LLVM is called LLVM because it's a low level virtual machine. So what we are doing is a lot more high level. Looks like it's doing SSA. I'm not sure. I'm not sure if Rust does that. Like there is a mutable variable here, right? So it actually mutates the things. No, I guess a single assignment is not always possible, right? But yeah, the language is similar to Lisp. Kind of. It's actually kind of like a Lisp without the Lisp syntax, what I'm doing here, I guess. The way my my macros work. Typed Lisp, yeah. Initialize expression. Span HT expression shape. I just have the span here. This. Okay, I was working on my generics here. So I have elevated the argument of the generic, and then I need to actually call it. Call this function to figure out the type. I'm just wondering because like previously template cast is cast with scope new, not recursive. Oh wait, I understand now. Okay, this makes sense. So I was evaluating my templates using a new scope with no parent. That way I don't like leak the current environment into the template. But also I'm not sure if this is like actually correct, but okay. I'll do the same thing for now. Yeah, so I want to have cast interpreter dot I want to call untyped function. I want to call untyped function with the span, the interpreter state, template interpreter, or I guess I call them generics now. Generic type interpreter. I call this with the argument, and that's my result. And then we do result, expect to be a type. And if it is a type, then I return type. If it's none, then return an error. And I do generic type. It's not a type. Although technically that should never happen, I think. The result is a value. Yeah, because what am I calling here is the generic type. Okay, so what is generic type interpreter? I'm going to just say that it is state interpreter for now. But it should be something else. And then generic type itself. Yeah, I see. And then I'm doing the pattern matching here manually, kind of. Okay, but I want to actually just call the untyped function here. Which means that I need to create this untyped function, which is the generic type. This is a untyped function. Which is ID definition and captured. It's going to be capturing. It's not going to be capturing anything. It's going to capture the generic type interpreter, right? Captured is a generic type interpreter scope. ID is ID gen. And then it also has just the definition. Right? Okay. Is that all that I need to do? Not exactly. I think one of the things that's missing. So what is the type of a generic? What's the type of a generic? That's the question, right? What's the type of ID? How do I figure out the type of ID string, right? I need to create a new generic, basically, which is called ID type, which is very similar to this, but the only thing that we're going to add here is we are going to add type of here, because because that's what we need to figure out the result, the type of instantiating this generic. So in order for this to work, I need the type of operator also. because that's what I'm doing here, right? I'm literally just calling the function. Literally just calling the function here, but this function is not the function that returns the actual thing, but it should return the type. So we just wrap the entire thing in the type of. That's how I was doing it before, right? Macro template definition expression initialize expression template typesheet template compiled clone. Or am I not doing that? Expression instantiate. Template type is this. Oh, yeah, it's not actually doing this. It's just saying that the type should be the same as the body of the compiled function. So I'm doing it like manually here. Yeah, okay. But basically the same thing. Yeah, I guess it can be done without the type of. But if I do the type of, it's just going to be easier, I think. Let's because then I will literally just call the untyped function here. Right? Right. But then it means that this definition is not the actual definition because it's different from the type. What's my compiled? This compiled function? Yeah, it has a argument, body, and evaluated result. Which means that do it directly on the expression generic. Maybe, but I don't want to compile it twice. I don't want it to be compiled twice. But that's not really difficult. Because if I have the definition here, I can change the definition, this untyped function. I can change it a little bit. Because I can, first of all, I can wait for it to be compiled, right? I will need to, for it to be compiled anyway. Definition is... That's interpreter await compiled definition, right? Span. Now that I have this definition, this is an option. So we do option unwrap or else. Return error. Also over here, I guess I want to log it. Span. Tried to instance expected generic. In this case, I will also say that generic is not compiled yet. So now this is a compiled function, and I will actually rewrite this compiled function. Definition of the type. This is also compiled function, right? Compiled has argument, body, and evaluated result. I don't think I need that. Might actually need to remove it from here. But yeah, what is argument here? Argument is going to be the same as the original argument, so it's definition argument. But body, I'm going to wrap the body in the type of operator, right? So it's expression type. No, it's not expression type of even, right? The body is literally just a constant. It's literally just a constant with shape being a type, and a type being definition body data type. That's all. But this must be an expression, so I need to initialize expression. This needs to be recursive. So I initialize expression. Span is going to be the same, I guess. Definition body data span. The state, I can initialize it using my current state, I think, and that's it. So now we have the definition type, and then definition is definition type, and that's what we evaluate. Definition is compiled is this. So like I already have the compiled thing. There you go. Okay, that's a little weird, but I think this should work. Does it work? The code runs. Does it? It doesn't really mean much though. Oh, there you go. I think it works. Look at this, and we also have inference here, right? So we have a function. We have a generic function to string, which is instantiated with the underscore, which means that it's supposed to be inferred. So this is inferred based on this argument that I supply to this thing now, and it works. Yeah, and this over here, id string is a string into string, and id int is an int into int. This works. id actually works. Okay. So yeah, the implementation right now is basically the same as the old one. So yeah, we'll see if there are issues with it, but it was working pretty well before, right? Hello, Brainoid. Okay, so we have generics. That's great. Should I write? Oh, now that I have generics, I can do things. I can do things now. Yes. But maybe let's just have generics as a separate example first before I continue working. What's a good example for generics? If not ID, just ID. I mean, ID is a good example. ID is T X T into X, right? There you go. This is the ID. Print ID hello world. There you go. Print ID 123 into int 32 to string. There we go. I guess. So one of the things that since like this is already being inferred automatically, we should be able to just omit the square brackets here when to do the auto instantiation. Fuck my life with project managers. I keep jumping from one call to another, and PMs just keep talking about obvious things and asking useless questions, and they are the bastards delaying things with their stupid meetings. Const. Oh, const is just a function that returns the thing, right? Okay, yeah, sure. Const. But const is a keyword for me, so I mean, I don't know how to call it. We can use the raw identifier. Const is so it's value into function that returns value, right? Where value is of type t. Like this. My language server crashes though. I still have some like like usually my language doesn't crash. Oh wait, it's timed out. It's timed out. B can be anything, not just that. But why would it be anything? Because we ignore the argument. I think this is better though. I mean, sure, we can try your definition too. Stopping the server. Oh, stopping the server timed out. Okay. That's weird though. I want to like figure out what happens when it crashes. Type check failed. This into that is not generic. What do you mean? Yeah, okay. Do you think that this the fat arrow should be associative, right? Like, do I need this parenthesis or not? Because this is a function that takes value and returns a new function, so it's the same as having the parenthesis here, right? The regular error, right? Like int into int into int, also is not parsing for me right now. The parentheses need to be explicit currently. I think it's okay with explicit parentheses for now. You didn't time out my language server? Generic. Wait, you know what? I want to like specify the type here in the thing. Can you not do two generic? What do you mean not two generics? This is ID, and this is const. This is one generic here, right? Or you mean, can I, or is that the question? No, I can't do. You want this over here to do the, you want literally to be A and B. So this is A of type A, and then this takes underscore of type B. This is what you want? No, I can't do that. I think the only thing that I cannot do right now is automatically convert a single underscore into two underscores, which is a separate feature, so I can do that later. But so we can try const instantiate this with underscore underscore. So this is going to be Can I not hover this thing? There we go. It's underscore underscore into type. Wait, it's not. Yeah, why is it's returning the type here? Because I did the capitalize A here. That makes sense. All right. So now we can do const using like 1, 2, 3, right? And that's going to be now a function that takes integer, takes anything, returns integer. Yeah. And then, so this is const 1, 2, 3, right? Const 1, 2, 3 is a function that. So this still is not inferred. If you talk about the Haskell, is this the same definition, or is it in Haskell the higher kinded polymorphism where this returns like a polymorphic function in the end? Can I try it actually? Let's try the Haskell one. I can do both though. It depends. Like it has different semantics. I don't infer the generic arguments like the Haskell does, and I think that's totally fine. But there's like two different definitions that you can do. The second definition would be that this would be a single generic argument, and then this returns another generic function which takes B, you know, like this. So in this case, const 1, 2, 3 is const 2 instantiated with something, and then you give it 1, 2, 3, and this is going to be itself a generic, right? Which you can then call like const 1, 2, 3. You call it with some random argument 4, 5, 6, right? And in this case, I'm actually wondering if I need to do something else. Let's try print. Print this hello. Oh yeah, but this is returning an. Oh yeah. See, this returns an A. That's wrong. Okay, I have a problem still. But we can do this over here when we print const 1, 2, 3 hello like that. But that is an integer, right? And we do int to string. Okay. Let's just do 1 here, 2, and 3. Right, so I'm printing 1, I'm printing 2. This third version doesn't work. Why does that not work? That's a question. But in Haskell, let's try Haskell real quick. I can just nix run the GHCI. How do you run the GHC? Just GHC? No, that's just GHC, right? iHaskell? What's iHaskell? Dun, 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 dun. What if I do nix shell? Is GHCI coming with GHC itself? It does. Okay, there we go. GHCI. So we do const x underscore is x, right? Just like this. And then the type of a const is this, p1 into p2 into p1. So then I want to say that yeah, so now I want to say like const1 is const1 is const1, right? So now I do const1 hello, and this is going to return 1, right? And then I want const2 is const2, and then const2 hello is also 2. But what if I do const2 1 2 3? It also works. Why is that? The type of const2 is p1 must be a number. Okay. I guess it's like the way type inference works in Haskell. Because over here, over here I'm like applying the function partially. So it keeps the second one as still a free variable, and it makes it a generic variable of this one, kind of. Okay. Yeah, but for me, it's going to be like 2 separate things. All right, and why is this? String is not A. String is not A. This is taking string and returns A. Because this is of type A. That's right. I know why. I need to substitute the bindings there too, right? Or wait a second. Or should I? You're not able to define function of type for all A for all B in Haskell. You need an extension for it. Haskell, higher kinded types. No, higher kind, Haskell, higher kinded polymorphism. Kind polymorphism. I'm just like, what's the where's the link to the actual Haskell docs though? Kind polymorphism and promotion. That's a little different. Maybe it was something else. It's called higher ranked polymorphism, maybe. Higher rank, arbitrary rank polymorphism, right? This is the extension. Arbitrary rank rank and types, right? And stuff with explicit for alls. This one. So this allows you to have the for all over here on the right side, right? So you can have a function that returns something that's for all, because by default you can only have the for all in the beginning of the function. All right, what I need to do here is I need to substitute the binding when I instantiate this. No, not even when I instantiate this, because this is A. So when I evaluate that, I think I understand what's happening. It's also is because this is a generic here. So when I evaluate this expression, I know what A is, right? But this is still kept as the original thing where A is typed A, which makes sense. Or does it? So what's happening is I'm trying to figure out the type of this. In order to figure out the type of this, I'm just oh wait, this is A. Yeah, this is A over here. This is A. This is B. Hold on. So this is a generic. You know what? Let me do the better let me do the better hover information here, because just generic is not enough. But let me anyway basic generic type inference. We have something working at least, so I should commit. Let's do LSP, not LSP, right? I need to print the type of the generic, T generic, right? I'm just right now saying that it's generic, but that's not what I want. Type generic contains the definition. And I want to match. Rust uses associated types in this case, right? Well, in Rust, you cannot have a generic lambda at all, and all of the generics are... like, you cannot have a generic as a value in Rust, right? In Rust... you don't have a type... I mean, the only generics in the types of Rust is the generic lifetimes. Other than that, you cannot have anything generic as a value, you know? Rust works differently. Like, you cannot really write the alternative of this function in Rust at all. Because what you want, right? What I want here is I want to write a function... const, right, which takes function A. So this is a function that takes A of type A, and this should return 4B B of type B into A, right? You literally cannot write this in Rust. This is this for syntax is existing, but you can only use it for lifetimes. You cannot have this for regular types, you know. Although technically, like, if we do it not for the functions but for something else, let's see. What if I have like a struct const 2 with A, right? Where A is A, right? Something like this. Let's make it copy or whatever. And then we have implement const 2A, where A is copy, where we have like apply. So like it's basically like a function, and we apply this function for all B's, where B is B, and this returns A, and then we return self A, right? Something like this. That's what we want. That's the alternative, I guess. Right? So in this case, const 2 is const 2, where A is 1, 2, 3, right? And then we say const 2 apply hello world, and then we like debug it, and this is going to print 1, 2, 3, right? It doesn't know what B is in this case, but it doesn't matter. I mean, the B only, the B is like, because this should work for all the different B's, right? So I should be able to apply this with hello world, and I should apply this with some other integer too. You know, this all this works. I guess this is the alternative, but you cannot have it as like basically what we do here is we say that A here is like I32, right? Yeah. Like, you cannot have a generic function as a value, but you can have a struct with a generic method. That is possible. Yeah. Because functions are not first class. Generics are not first class. That's why. Because generics only exist at compile time in Rust. Same as you cannot store like a type in a variable, for example, because types are also not first class in Rust. But I can. We can just say that let foo is integer and foo is a type, right? That's something that you cannot do in Rust. We need it for driving the compile time evaluation. Okay, so if this is compiled, argument body. Can you do it in traits? Yeah, I guess like trait is like a language in Rust where you can do a lot of things. Okay, I just want to say that this is a generic. So how do I print it? Printf. Argument in this case is a pattern, right? And I just print it as is, yes. With square brackets, this into body type. So we do pattern, print pattern. With spans? No, not with spans. Not with spans. I'll just say print pattern. I need to do a new function. Print pattern argument and print type body data type. Let's do this. So what is a print pattern? Let's implement it. Because this is like the debug printing, but I want not the debug one. Print pattern formatter pattern unit is function fmt shape. I'm going to match shape with these ones. So if it's a placeholder, then I just print underscore. Sure, unit is unit. This over here should just be a print binding. Why write your own language? Hello Melty 1000. Because we can, because it's fun. Most important reason is because it's fun. Have you tried it? I don't know, I literally cannot stop. Too much fun is being had. But also it's because there are a lot of issues with existing programming languages and I want to fix them. To see if I can fix them. The only vibe codes who not have an agent database or context for my AI to work from would make what I do impossible. I see. And print. Print using this function. Just print pattern. FMT tuple. There we go. That's all that I need, I think. The constant of type string, but expression was good of type formatter. Print pattern. Printf FMT. There we go. Fix it though. What's the purpose of the language? The purpose is everything. I wanted to be able to do everything. But yes, I am most interested in making games. But it is a general purpose programming language. That's a big task. Yeah, I know. The language that I'm making is very overscoped. It's... Yes. It will take forever to finish. Probably. We'll never finish it. But like I said, I'm having fun, so whatever. And maybe... maybe like at some point it's going to be like usable enough that I like drop my my wishes for having the like the everything language, and we just like polish what we have and you know, something. I'm just like exploring making a programming language, I guess, right? That's what I'm doing. What can I do? Type inference failed. Okay, yeah, I did not do that. So what I did right now is that I should be able to hover this. Yeah, there you go. So see, const3 is a generic which takes B argument and returns A, right? So the problem is that this is wrong, because this at this point A should be inferred already, right? Because because const v2 has been called with the integer, which means that A should be integer, right? So this over here is incorrect, this inference. But const2 itself, but yeah, const2 is fine, and const v2 is this. Yeah, there we go. So const v2 is A into that. My brain cannot even wrap around the idea of making my programming language. I guess I would need to have an idea how a language functions to begin with. Like what's behind the doors. Well, I also didn't know how to make a programming language before I started this here, but I do know how to use a programming language, right? So I know how it should behave, the final thing, right? I know what I want to make. I didn't know how to make it. And then I'm just figuring it out as I go here. Because I am a programmer. I've used programming languages before. I know what I want. So what's the issue here? Const v2, let me put that here separately maybe. The const v2 is this. So when I instantiate this thing here, using that, we can see that this was replaced with a, but this is not replaced. So like, yeah, this a was replaced with an integer, but this last a was not replaced when I actually instantiated, and that is a debug. Side question, why haven't you not activated Linux? Because I am broke and I cannot afford the license, of course. Because I'm working on a programming language, which is basically the same as doing nothing in terms of getting money, you know? Because I could go and work instead and earn some money so that I could afford the license, but I'm not doing that. All right. Would this work in my previous version though? That's the question. Let's try this in my previous version because I'm not sure. Let's do this. Const f is, and over here I had a different syntax, like for all, I think, right? For all a into a of type a into for all b b of type b into a. Oh, wait, it actually needs the curly braces in this version too. Like that. So f is this. So then I do f int 32. Let's say f int 32. Or I guess just f 1, 2, 3. F 1, 2, 3. This is just a template. I'm not even showing the types here too. Okay. F 1, 2, 3. Hello? I have the same issue in my old version. All right. It was buggy before. Okay. Okay. Now you can ask more questions if you want. I'm not really busy. You know, I can multitask, I can chat and work on my language at the same time, right? The issue is you. Yeah, I guess. Okay, so it didn't work before. Maybe this time I actually figure it out. How do I do this? So it means that when I instantiate this, the type is that. Okay. But the problem is my... let me commit what I did though. Printing generic type. So the problem is that my generic type is just storing the maybe compiled function, but I feel like it should also store Or what should it store? Like, any advice for aspiring software engineers? I don't know if I'm a good person to give advice. But just do whatever you feel like doing is my advice. Just figure out what you want and do that. And by doing what you want, you become good at doing what you want. So you do what you want and you are good at it. So you can also maybe make money with it too, if that is what you're after. But if you're only after making money, then figure out what is the thing that is allowing to make the most money, I guess, and then do that. And then if you want both things, then I guess you need to find the balance for yourself. It depends on your self. Just figure it out. I don't know. What advice are you looking for? Like, I feel like I still needed to be typed. The generic types, right? So yeah, I was like having the untyped function. But shouldn't it still be typed here? It's when I am in the interpreter and I'm evaluating the expression generic. I'm having this value. This has the definition. And the problem is that I'm not substituting the types here, so I'm losing the information. So I need to keep the information here. One of the things that I could... I mean, do I just change the definition, though? I could. When I create the generic, do I need to... can the generic be a not compiled function? That's another question. Probably, because we want to have like mutual recursion on generics. Actually, does mutual recursion work right now? What if I make generics and I try mutual recursion, right? So I want to have function f. Also, kind of like, can I do this with lets right now? I'm not sure. T, xt, into have parentheses right now. Okay. Riven main. Hello, hello. What if I try to call here gx? Gx. This will need to be a module so that I can have the function g, which also is calling function f recursively, right? This seems like this doesn't work. Or does it? I don't have the... Is my language server crashed? I cannot hover anything. What if I try running this? Oh, I actually crashed. Yes, okay. Exception to do await inferred. When I instantiate generic, generic data type variable, it's not inferred yet. The type is not inferred here. To do await. Oh wait, it's because I yeah, I need to make it actually async, right? Yeah, there we go. That's why. That makes sense. Maybe I implement this now. I implement this now. This is very similar to awaiting the symbols. In the compiler state. So I need to do a new effect, which is going to be await update or await. Let's do await inferred. Inferred. Await inferred. I'm updating an inferred variable. Right? So literally what I'm doing here. This is just going to return a unit. So it's inferred and we will be able to get it, right? So I just do effect perform await inferred variable, and then after that I just loop here. So I do await inferred, so this is just going to be recursive await inferred variable and just loop. Okay, sure. Although technically, like after I loop, it should always be that. So I kind of, maybe I just do it manually here. And I say that I find the root data again, and then I either return inferred, or over here, I say that this is not inferred, and this is where I actually panic. Fail. Inferred. Awaited. Inferred. But it's not inferred. Yeah, this panic should be fine, because it should not panic, since I awaited it, right? And now I need to actually handle this effect. So a type variable just has the state. Actually, you know what? We just await the update then. And then we actually loop. You know? So on update, just like I did previously, is a list of functions, unit into unit list. Right? Whenever I update the state here. Guess that's easier. And then I do it literally the same, await update. For variables, await update. And then I actually just loop. Wait inferred var. And then we have a function handle awaits, right? Which is taking a function like this. So we just call the function here, but we want to call the function handling this effect with effect await update variable and k. Then we say variable on update is variable on update plus the function that is going to continue the k. A record on update is not mutable. Yeah, it should be mutable here. This is just type unit, but expected expression of type A. Oh, wait a second. How should this work? Because it's when I continue k. Try f. K. K. Why can't I hover it? Okay, effects continue. This expression has type A, but expression was expected of type unit. Yes, that's right. Because once wait, what? Hmm. Mm, 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 mm. Await update. Uh, I didn't like really do this thing yet. You know, camel, I guess. Um, like when is this going to be called? For the scopes, I have specific things. Yeah, so like yeah, this is like tasks. This is tasks that I do. This actually must be unit ones, and we return a unit thing because like this is where we spawn a task, which is what we call fork, right? Then this type checks, of course, just like before. So I can only await inside the forks. And when do I fork? I fork in the same places where I fork for my other things. And this fork. So maybe in this fork I just call the inference fork, inference bar fork. Wait, no, that's not what I do. I do it on the outside, right? Inference variable fork into this. Fork is unit into unit into unit. So we just do cast inference fork. Does that work? Who knows? Well, I don't compile currently. Inference base. Yeah, because now when I I finish this. When I initialize, we have the state and we have on update is empty list. On update is empty list, right? And when I say state is going to be mutated, right? In all of these things, I should call an update. I guess in find root var, it's not like really needed. It's only when I'm merging, only when I'm uniting it here. And over here. Once inferred is wait, we have a once inferred, which is already storing the once inferred functions there. So I can do just that. That's an existing method of doing that. Call the list of functions once this is inferred. Sure, let's do that. Let's not do on update then. I think that's already solved. Once inferred, we do that. Okay. So yeah, when I fork, when I await update, I just say that once inferred, we have a function that ignores the inferred value and just says that it continues here. And we do that for the variable. That's it. How long have I been developing my language? And you type in assembly or what? No, this is not assembly. This is called OCaml. That's what I'm typing right now. But the language started a year ago, a little more than that, I guess. But then I have been rewriting it multiple times. This is rewrite number 3. It was originally made in OCaml, then I rewritten it into Rust, and now I'm back to OCaml. This specific rewrite is like maybe like 2 months old or something like that. Maybe more than that, I don't know, I don't really count. What did I just do? I have the envoy inferred now, yeah, so this works. I will just have the type checks. Okay, yeah, but this now works, right? This works is what it means. The recursive things. This says type check failed. T is not T. Wonderful. Wonderful. T is not T, of course. But yeah, this works. We can refer to generics. Okay, let me commit that. Await inferred. Type check failed. T is not T. I'm so like the reason is because this T and this T are not the same or something, right? Rust dev makes new language. Classic. How many other Rust developers have made their own languages already? Is this a classic? I don't know. But I don't get it, so I can make my own language using C, for example. You can make your own language using anything. Any language can do anything. I mean, most of the languages can do anything. C is one of the possibilities, sure. That making my own languages by not using any language. No, you use some existing language to implement a different language. Right? You use some existing tool to do a different thing. Step 1 of developing a game is to make your own programming language. Right, exactly. Why is this error here? T is not T. Let's call this argument not T, but G, right? Because then we are going to have a different error. It's going to say that T is not G, right? That makes sense now why T was not equal to T, because these two generic arguments are different. I tried to make embedded systems. I tried to be embedded system developer, and then the market and country got cooked. Switch to web development, the classic. I think I want to change my formatting of the generics. I should actually just do never. Here and here, never wrap. Just change the formatting like this. So am I a web dev or a game dev? I'm just a dev. I'm just making all kinds of things, I guess. I never really did the embedded development though, I guess. But I do web development, I do game development, I do programming language development now too. Saying you're a web dev or a game dev is like saying you're a while loop dev and don't use if statements. T is not G. T is not G. And string is not A. Why is that? What if I make this explicit FG? And this is explicit FT, right? Because that's how it's supposed to be. Although that's literally the same thing, right? That should not matter. Is this parenthesis needed? They're not. Let's simplify this even more, like this. Can I rename this, by the way? TF. Oh, my renaming works. Look at that. And G. F. It's not G. Would this work in my old version? That's another question that I have. Is this an old bug or is this a new bug? It's probably, I would expect that it's an old bug. Let's see, do I have examples here? 0ks. Let's do it in hello world here. It's like just a slightly different syntax currently than in the previous version. Right? Cast examples, hello. Target the backcast is not a file directory. What? Oh, it's called cast bin now. Okay, we just do cargo run. Cargo run examples. Hello. Cannot finish parsing. Okay, so yeah, because in this version we do a for all, and we do a for all, and we do curly brackets here, right? I think that's the only thing that I need to change. Expected type underscore. F and G got unit. Wait, what? Oh, there you go. Okay, this actually, so this evaluated, which does it mean that it works though? That doesn't mean it really. Can I do? Can I run it? Can I run it? Let's try over here. Print F. Because it's maybe it's just not reporting the error for some reason. Right, so what if I do who is this? We can do like foo.f to 3. Number literal type could not be inferred. 1 2 3 inch 32. This works. This actually worked. But what if it just... Okay. GG. Well, it's not GG because it's just working in my old version, which is... I mean, I need to figure out what's different then. This is my new version. Where it doesn't work. We have the type check failure. For some reason. Let's see how type checking here even works. Like, let's see how type checking here even works. So the reason it doesn't work, I think, maybe if I do over here 1 2 3, I'm going to have a different error. No. Oh, it's because I'm calling F over here 1 2 3, and it's going to say that integer is not it, right? So it is reporting this error when I'm trying to call this with G. Why am I not having the error being reported for this second X then? Like, shouldn't I have the error over here too? X, X. You know? Like, this is a function that takes G and returns underscore. And this is a function that takes G and returns underscore. That's weird. Sure it's not just syntax that you've changed? No, it's not just syntax, it's the entire rewrite. The previous version was in Rust, this version is in a Camel. We have been rewriting things, so there could be some new bugs or some bugs in the old version. The bug is somewhere. This thing was not working before either, but this thing was. So what if I just have a normal function? What if I just have a normal function? Instead of this, so this is going to say that f is not found, right? What if I just say f? But this cannot be generic anymore, right? Yeah, this cannot be generic anymore. The type of fg is g into underscore. Last time I made a dashboard web page for my home server with HTMX, SSE to keep the display data up to date, and of course iOS Safari event stream doesn't reconnect when I background the browser, then open it again. Copilot not even set up is a new form of protest. I don't think Copilot would help me here. G into underscore, which is correct. Maybe like in practice, I can like get pretty far without this being resolved, and I can get pretty far without this being resolved, without like generics returning other generics. But I should solve it eventually. It's just maybe I can delay this for later. You know? What if I try to do something else? I'm going to end the stream soon though, but the reason I wanted generics, for example, is because of equality, or like operators in general, right? Because right now, when I say like 2 plus 2, it can only work for integers. I cannot say like string A plus string B. Because syntax ks over here, I'm rewriting my plus like that. And I wanted it somewhere. Where did I want it? Maybe in std path. Std string. Oh, over here, equality. Yeah, equality was only working for strings, that's right. Let's actually, yeah, maybe I can fix this. So here we go. If I try to do this, target name is equal to interpreter. This is going to not work, right? Because it says that int32 is not string. And the reason for that is because the equals only works for strings currently. So let me see if I can do it really quickly. CMP. So yeah, less and all of these things. This should be generics of type T, right? Function AT into BT. I think for like and to change the priority of the generic. After all, it should be lower than the function. Should be like 6.5, I think. This works. Seems like that works. So yeah, it's just it should be just generic, like this. Replace all int32s here with t's, and add t's over everywhere, right? Like that. And then in this syntax, this should do this comparison operators with the inference of the argument. I must do explicit inference right now, but that's it. Unexpected opening bracket in generics. Yeah, because this doesn't work, I guess, exactly. These parentheses here now. Field must be ident. Oh, I see. So the priority of the of this thing is also wrong, right? Because when I'm instantiating a generic, this thing should be the field. Would be the field. So the dot, which means that instantiating generic should have the priority less than a dot, I guess. So it should be 65. Pseudo? Wait, why did I pseudocast? Now we just have the inference failures. Okay. Does this work, actually? Let me just make sure. Where did I change something? In std string, right? So if I run the examples advent of code thing, right? And then it still works, which means that this actually works. And now I can simplify my code. Nice. So if target is interpreter, it's just like this. And then there is over here the comparison of symbols. This also can be written now simpler, like C is equal to C at I. And this over here can be written as C is equal to C as I. And this can be written as C is equal to /n. Because it's a generic operator now. That's nice. Let me look for native equals. I think not in this module though, or at least not in inner terms to define the equal, because that would be a recursive definition of equal using equal. Okay, and this still works. Okay, there we go. Generic comparison operators. All right, but this is good. This is good progress. Generics are kind of done. So that's going to be it for me. I need to go now. I need to go.
Because the server only sends new inputs.
All right, see you
which
guys
is what
next
it
time.
should be. So really, the
Bye.
received is what the send should be. Yeah.